discuss with you on periodic classification of elements. Before that, what is classification, or how can we classify things? How do we classify things? We just classify them according to their physical properties. Some may be having common physical properties, some may be having other properties, etc. So we will be classifying them and grouping and classifying them into particular groups according to their appearance, color, or for what purpose they are used, etc. Similarly, chemical elements are also classified. And this classification of chemical elements is called periodic classification, which we used to study as a modern periodic table. And now, some scientists worked on this periodic classification of elements. Among them, one was Johann, Wolfgang, Dobereiner. And his classification was called as Dobereiner's triads. Okay. So, Dobereiner's triads, the word triads, it's related to something 3. Okay. So, he told that let there be 3 elements A, B and C. Now, these elements are arranged in the increasing order of atomic mass number. But in the modern periodic table, elements are arranged according to their increasing atomic number. Here it was atomic mass number, but now in the modern periodic table, the elements are arranged according to their atomic number. But in olden times, in their times, they considered that there was a very big relationship between the atomic mass number and the physical and chemical properties of the elements. So they just grouped them according to their mass number. Now, when 3 elements are arranged in a triads according to their increasing mass number, then the mass number of the middle element will be approximately equal to the average of the mass number of the other 2 elements. That is, consider, let A may have atomic mass number of 4, C may have 10. So, what did Dobereiner said? Dobereiner said that the average of mass number of these 2 elements, that is 4 plus 10 by 2, 14 by 2 equal to 7. So, the mass number of B should be 7. This is what Dobereiner said in his classification. That is, he said that Dobereiner showed that when elements are arranged in the increasing atomic mass number in the form of a triads, the middle element, okay, the mass number of the middle element will be roughly, approximately, not correctly, roughly equal to the average of the atomic mass number of the other 2 elements. See, this is what. Now we will take some examples. Consider chlorine, bromine and iodine. Consider this triad: chlorine, bromine and iodine. For chlorine it is 35 and for bromine it is 80 and for iodine it is 127. These are the mass numbers. Now, what did Dobereiner said? That the average of the mass number of these two elements will be equal to the mass number of the middle element. So, 127 plus 35 by 2 equal to 162 Okay, so see, 81, 80, they are approximately equal. So these three forms are triads. Okay. So chlorine, bromine and iodine. Chlorine is having mass number 35 and iodine is having mass number of 127. The average of mass number of both these will give the mass number of bromine. This forms a triads. Now next, another example is lithium, sodium and potassium. These three forms are triads and their mass number is 7, 23 and 39. Okay. Now applying Dobereiner's law, 39 plus 7 by 2. What is it? 39 plus 7 by 2. Which is equal to 23. So, see, this is the mass number of sodium. So, both these have successfully fulfilled the Dobereiner's triad. So, these six elements form two triads each. Okay. So, what did Dobereiner said? Dobereiner showed that when three elements are arranged in a triad in the increasing mass number, then the mass number of the middle element will be approximately equal to the average of mass number of the other two elements. Okay. But there were some limitations for Dobereiner's triads law because he could only find three triads among the elements which were found at that time, and this happened in 1870. See, only some elements were identified at that time. Now at present there are 118 elements. Among them 94 elements occur naturally and the other 24 they just occurred accidentally through some nuclear reactions. So he could only find three triads from those elements of those time, and the other elements could not form a triad using this Dobereiner's law. So that was a very big limitation for Dobereiner's triads. For example, nitrogen, phosphorus and arsenic. So these are three elements which are arranged in the increasing mass number. Okay. Now check. 14 plus 75 by 2. This is 44.5, which is very much far away from what we have to get. That is, mass number of phosphorus is 31 actually, but we have here got it as 44.5. So these three do not form a triad, and this was the limitation of Dobereiner's triad. Then came the next scientist named as John Newland. He gave a new method of classification known as Newland Law of Octaves. That is, he was very fond of music. So he just compared those chemical elements with music. Interesting, right? So what he did was, he just wrote all the 7 octaves of music, that is Sa, Re, Ga, Ma, Pa, Dha, Ni. Again Sa. Again comes Sa. So this were the 7 octaves of music, and he arranged the chemical elements according to this. That is, first hydrogen, then actually it comes like helium, but at that time noble gases were not invented. So hydrogen, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon was not there, then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, then titanium, and it goes on like that. So what did Newland do? He just wrote all the octaves of music, and then he arranged the chemical elements according to those octaves, and he told that every 8th element had properties similar to that of the first one. That is, he just told that every 8th element in this table, every 8th element had a property similar to that of the respective first one. That is, consider lithium. 1, 2, 3, 4, 5, 6, 7, 8. So when lithium is a corresponding first element, then its corresponding 8th element is sodium. Both these having same properties. They are soft and they are alkali metals, and their valency is 1. So they both are having same properties. So it was exactly correct. Then next, fluorine and chlorine. Consider fluorine. 1, 2, 3, 4, 5, 6, 7, 8. So fluorine and chlorine. The 8th element fluorine had properties similar to that of fluorine. Both are halogen families and both their valencies are same, and they just form hydrofluorides and hydrochlorides. But there also this had many limitations. That is, one of the limitation was this Newland law of octaves was applicable only up to calcium. After this, there were many titanium, vanadium, manganese, ferrous, etc. So those elements could not be applied under this Newland law of octaves. That is, after calcium, not every 8th element had property similar to that of the first one. So this was applicable only up to calcium. After this, it was not applicable. And another limitation was, at that time only 56 elements were identified, and Newland thought that further no more elements would be invented, no more elements would be identified. So he just considered only these elements, and for these elements alone he just made this law. He didn't ever, he might haven't ever thought that in the future there will be many elements getting invented. So that was a very, very big limitation of this. And the third limitation is that In order to fit into this table, Newland adjusted two elements in the same slot. But that was not the problem. He arranged some unlike elements under the same slot, which we can see in the figure. For example, you can see that cobalt and nickel are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, which are halogen families, and their properties are exactly different from cobalt and nickel. So, this was a very big limitation of Newland's law of octaves. Thus, Newland's law of octaves worked well with lighter elements only, till calcium only. After that, this was not applicable. Then came the most famous scientist, Dmitri Ivanovich Mendeleve. He had many studies on this, and then he improved a new type of classification known as Mendeleev's periodic table. At his time, there was some improvement, and there were 63 elements invented. So he just made studies on these 63 elements. How did he do this? Was he just took 63 cards and wrote similar properties, or he wrote properties of one element in each card, and he just sorted out which element had same properties, and he sorted out all those similar properties elements and then pinned into the wall. And what he saw was that when elements are arranged according to similarity in their properties, they were getting arranged automatically in the increased atomic mass number. Did you get that? Like, he just took 63 cards and then he wrote similar properties. So, in each card, he wrote the corresponding properties of those elements, and then he just arranged them according to their similar properties. Which elements are having a similar property, he just sorted out it, and then he could see that when he sorted out them as similar properties, he saw that they were automatically getting arranged in the increasing order of their mass number. From this arrangement, he gave a new law called periodic law, which states that the properties of elements were the functions of atomic mass number. This was the periodic law given by Mendeleve. So what did Mendeleve tell? Mendeleve told that the properties of elements were the periodic function of atomic mass number. That is, the physical, whether it may be a physical or a chemical property, those properties were these properties were the main basis for the function of atomic mass number. So the atomic mass number and their properties had a very big relationship with each other. That is why when he arranged these cards according to their similar properties, they got automatically arranged in the increasing order of mass number. So this was Mendeleev's periodic table, and this was his periodic law. And he also told one more thing, that there occurred a recurrence of elements with similar properties after a regular interval. That is, see, this is Mendeleev's periodic table. Here, considering lithium and sodium. Lithium and sodium are alkali metals, and after a regular period, lithium, sodium, potassium, they occurred after a regular interval, and both these and three of these had similar properties. They are alkali metals and their valency is 1. Same as fluorine, chlorine, bromine and iodine, they are halogen family and they occurred after a regular interval of time. So this was all about Mendeleev's periodic table. But here also there were some limitations. That is, see the Mendeleev periodic table. He was confused whether hydrogen should be placed in the sodium alkali metals group or in the halogen group. This is because hydrogen, the electronic configuration of hydrogen resembles that of the alkali metals because valency is 1. So it resembles with the alkali metals. And also, see, this is halogens. Okay. Similar to halogens, like they form diatomic molecules Cl2, Br2. Hydrogen also existed as a diatomic molecule. So whether hydrogen should be placed in the alkali metal family or halogen family, there was a confusion. So this was the limitation of Mendeleev's periodic table, and this was also not successful. And finally, our modern periodic table was invented. It was invented by Henry Moseley. He said that properties of elements are periodic function of not atomic mass number but of atomic number. So after this was the modern periodic table, in which the elements were arranged in the increasing order of atomic number, and this was successful, and this is the mode of classification which we are using now for classifying our chemical elements. Thank you for watching my video and supporting me. If you have any suggestion, you can just comment below, and we'll see you soon with the next video. Bye.